Right, folks, I'm using my sister computer. Right, question 4. We know that a vertical force of 200 Newton is required to remove the nail at C. What is the P required if alpha is 10? So I now know that alpha is 10. And I know that in order to remove the nail, I need to exert a force of 200 Newton upwards, okay? So, with that, my reaction force is basically this side, 200 Newton. Okay, maybe I don't cover the 400. I mean the 4 cm. What am I doing, bro? Alright. So, in order to remove the nail, I know I need 200 newtons. First glance at this question, we know that we require moments to solve for part A, which is to find P. So for moments, we know that we need to have a pivoting point. And this pivoting point needs to be connected or have relations to the forces that are going to be applied. For the nail, we can see that the bar is connected to the nail coming towards B. Okay, so I'm just going to assume that B may be my pivoting point. And then now, let's look for P. Okay, maybe pink's not good. I don't know, maybe I use... I'm just going to use black. So for P, we start from A, and we travel down to the bar, and it connects to B as well. So because these two forces connect to B, we shall use the pivoting point at B. Okay? So let's run through the basic. Moments of any point equals to force times perpendicular distance. Okay? Is this readable? Perpendicular distance. Why did I put 20? With that, let's try to find the P. So we know that this P, or the moment induced by P, will be P times 18. Okay, and then the moment induced by the nail will be 200 times 4 cm. But in order to be able to use these two equation into one, we have to first assume something. And that is moment about B equals to 0, aka equilibrium. Why equilibrium? Let's say, for example, for my P force, the moment may be greater or much more needed than what I need to remove the nail. Then in this case, I don't really have 200 Newton acting on the nail. I may have 300, 400 Newtons, and that's overkill. I just want to know, the just nice amount of P, which is why we are assuming equilibrium. Okay? So, now let's assume anti-clockwise is a positive value for moments. So moment induced by nail plus moment induced by force P should give me 0. At this point, I don't know which moment is negative, or I'm assuming, or I'm not putting a polarity into the moments yet. So let's go ahead and do that. So as you can see, for the nail, it's going in a clockwise direction. Whereas the P is also going in a clockwise direction, so it doesn't matter, okay? They're just going to equal to each other. So since equilibrium, I can now say the moment about nail is equals to moment induced by P. Oh, sorry, the moment induced by the nail equals to the moment induced by force P. And let's just, okay, I'm just going to go through it much slower. So remember, moment is force times distance. So moment of nail is basically force from the nail times distance from nail to B. Okay? And then for moments of P is basically force of P times distance from P to B. Okay? Then the force of nail is basically 200 newtons times distance 4 cm convert to let's convert it to meters, shall we? So it's 0.4 times. Now for force P is very, very weird. Okay? Why do I say so? Remember, my force and distance have to be perpendicular to each other. In this case, is P perpendicular to point A? No. So, in order to make it perpendicular, let's just continue using black. I don't know. What about if I erase? Can I erase? Oh, I can't. Oh, I'll erase the thing as well. Oh no. Okay, never mind. So, this thing needs to be 90 degree. Or not say 90. Yes, my P needs to shift up here. So my P needs to be over here. So what is this angle? Very simple. We have a 70 right here. Okay, maybe I should use blue. Is blue gonna help? Nah, blue's kind of meh, bro. But there's no good colors. Okay, maybe there is a good color. I just need to increase the size a little bit. Okay, so now I know that that's my 70. If you remember the angle law or whatever, these two angles equal to each other as long as this and this is parallel to each other. So this black line is parallel to CB or the floor, which means that this angle is 70. And because I know A is 10, this angle is 60. And then remember, I want to find this red line. So this red line is 90 degree to the board. And just nice, I can find what's here, which is 90 minus 60, which give me 30. So now I have find my angle. So coming back to the equation, force P is basically, or force induced by P is basically P cosine 30. What's the distance? We have 18. Okay. So now let's press the calculator. Oh, sorry, it's not 18, but 1.8. 1.8. Okay. So 200 times 0.4 gives me 80. And then cosine 30 times 1.8 give me 1.5588p. I like to leave mine in 5SF. It doesn't really matter. And then if you were to bring it over, 80 divided by the answer, you get 51.3. And this is my answer to part A. Okay, so I'm just gonna do this. Okay, now part B. I'm gonna do it over here. Part B. What is the smallest force P that can accomplish this task? So we must first try to understand how can we get the smallest P? It's basically when the angle equals to 0 of the perpendicular distance. What I mean by that is, basically, if let's say this is my bar, I'm just going to use blue, because the bar is blue as well. Okay, this is my bar. My force have to be perpendicular of the bar. This will give me my smallest P. Why? Because moments is basically force times perpendicular distance. So it's basically saying, like, in order to push something along the x-axis, I just need to move along the x-axis. The moment I have a y-axis involved, be it 0.1 Newton, 0.00001 Newton, it's still not going to be the smallest because I have a very small amount of force that's going to be acting in the y direction. So I just need to make sure that my force only acts in that one direction, aka in this diagram that I'm showing in B is in the x direction. Okay, even if, let's say for example, if I want to be very anal about it, okay, even if, let's say, I now have a force acting just like this, okay, as long as there's a degree, I am basically having more than required force because some of them is going to be translated into the y-axis, which is basically useless. So with this, I hope we can understand that why when my force is acting perpendicular to the distance, it gives me the smallest value of the force required. Okay? So with that, we now know that in order to get the smallest force, basically we need to run along this red line that I drew earlier. This red line. I know it's a bit hard to see. Okay? And we already got our angle, which is 30. So in order to find the smallest P, is basically you take the P times cosine 30. Which gives me 44.4 Newton. So that is the magnitude. Now I want to know what is the direction. Okay? Or like what's the angle? But here's the catch. Okay, I'm just gonna give you a. Okay, let's go back to this. How do I where the heck is a print screen, bro? Bro, my sister's laptop is, I mean, whatever. Copy. Okay, whatever. I'm gonna eat it here. Okay. Now we already know that this was 30, right? No, screw it. We don't even need to care about the 30 anymore. We know that this is 70. And here forms a 90 degree. So this means this is 20. And remember, my force is acting here. So what is this force in relation to absolute x-axis? 20. So there you have it. Your angle is 20. And this is question 4. I hope it's understandable.